global panel on higher airspace operations. As you may know, this is being organized in conjunction with 3 different events happening simultaneously: the ICAO Symposium on the Implementation of Innovation in Aviation, the ATCA Annual Conference, and the SESAR Innovation Days. So thank you all very much for joining. We will have hopefully a really good panel. We will at the end have the opportunity for questions and answers. If any of you wish to ask questions, there is a Q&A tab, and that's the place to post your questions. And at the end of the session, the moderator, if there's time, and we'll try to ask some of those questions directly to the panelists. We will also try to answer some of those questions in writing as we go through the panel. There's also a chat function, so if you want to make comments during the discussion without asking questions, please feel free to use the chat function also to interact with other members of the audience. So with that, I would just like to introduce our moderator for today. So the moderator is Mr. Silas, who is the Director General of the Rwandan Civil Aviation Authority. He's a member of the Board of Directors of the EAC Civil Aviation Safety and Security Oversight Agency, which is a regional safety oversight organization. He's currently serving as Director General, and before being appointed to the position of Director General in 2014, DG Silas deputized the Director General in the same organization, and he was responsible for airports management and operations, a position he served in for 7 years. And he originally joined the Civil Aviation Authority in 2007. So with that, I would please like to pass the floor over to you, Mr. Silas, and the floor is yours. Thank you.
Thank you for the introduction as we all learn more on the topic of high airspace operations. High airspace operations is an area of interest, which began in 1996. Its viability has increased due to evolution of technology through deployment of high-altitude platform stations as telecommunication platform to be located in the stratosphere, and advances in solar panel efficiency, battery energy density, lightweight composite materials, autonomous avionics, and antennas. Recent tests of HAPS technology to deliver broadband internet and mobile services using stations approximately 20 kilometers above ground have shown its ability to provide connectivity to remote areas and communities. Some advantages of HAPS is its ability to remain continuously over an area for very long periods in a persistent manner and permit better resolution images due to its close proximity to the covered areas. This is also the opportunity for positive and economic impacts. As with all new and emerging technologies, there comes challenges. Currently, there is no legal and regulatory framework to support HAPS operations, and there are still gaps in human resources in terms of knowledge and skills. Another noticeable challenge is designating long-term special use of airspace. This is taking into consideration of states' airspace already being shared by military, commercial, general aviation, drones, and their integration with air traffic management. Today, we hope that this panel will inform, educate, and address the questions that our industry has regarding the use of economic and business impact, legal and regulatory framework challenges, and assimilation of technology, and forge our way forward. Ladies and gentlemen, I take this opportunity to welcome you all to the ICAO, ATCA, SESAR, and panel discussion. I would like to take this moment and have each panelist introduce himself. We'll begin with Mr. Steve Bradford, who will be presenting on upper class e-traffic management. Bradford, please go ahead.
Hi, I'm Steve Bradford. I'm the Chief Scientist for Architecture Next-Gen Development at the FAA.
Next is is Henkoff. Do you have Henkoff here? Henkoff will be presenting on ECO, preparing the ground for safe and efficient higher airspace operations in Europe. If he's not here with us, then Dragos will do it next.
Hi, this is Dragos Tone, Eurocontrol. I'll be representing the ECO project and Henk as project manager. I'm managing the integration of new entrants in European ATM network. Thank you.
Thank you so much. The next on our panel is Mr. David Hansley. His presentation is on the challenges and opportunities in unlocking the stratosphere. David, please go ahead.
Hi, thank you so much, Silas. I appreciate it. My name is David Hansel. I am the head of Global Aviation Regulation and Policy for Loon, and I'm here today on behalf of the HAPS Alliance Working Group to discuss these issues. Thank you so much. I'm looking forward to it.
Thank you so much. We are supposed to be having Mark Valles. His presentation is on hypersonic developments using higher airspace. Mark, are you in here?
Yes, hi Silas. Hi everybody. So I'm Mark Valles from Dassault Aviation, and then, I am the director of space program of Dassault Aviation. And I will represent today the set of industrials that are working in the SESAR program in order to work on the integration of very high-speed vehicles in the air traffic management.
Last but not least is Paulo Villa from Peru. Please go ahead and introduce yourself.
Hey, good morning, everyone. My name is Paulo Villa. I have worked for more than 14 years in the aviation of Peru. Currently responsible of the air navigation division, and I really appreciate the change to introduce about the experience of Peruvian state with a high altitude platform station, the technology of the project. Thanks.
Thank you for your introductions. We will now go to the facilitator for the presentations. Please, over to you.
Hi, I'm Steve Bradford, Chief Scientist for Architecture and Next-Gen Development with the FAA. My organization and the people I work with are responsible for writing the concepts for UAS, UTM, urban air mobility, and what we're calling Upper E airspace. And today I'd like to discuss Upper E airspace a little bit with you and how it fits into international harmonization. So I'm going to share some slides here with you. So this is about our upper class E traffic management, ETM. In the United States, we designate all the airspace above flight level 600 as class E. I realize this is not the same around the world. So this is really what some people call space and other people call stratospheric operations. Our regulations for Class E airspace at lower altitudes apply equally at the airspace above flight level 600. And we have established separation standards for both surveillance / radar type and procedural type separation. Most of the references are specific to military operations, which have been predominant in this airspace. And these procedures have historically not been needed by civil aviation. However, that is no longer the case. The upper E airspace has been historically limited due to the challenges of conventional fixed-wing aircraft in getting above flight level 600. However, advances in technology to power, propulsion, aircraft structure, aerodynamics have led to an increase in the number of vehicles that can operate in this low atmospheric density airspace. So this increase in demand combined with completely disparate vehicle performance types, very slow movers, long endurance, unconventional operational needs, stay in the air for 190 days, etc., have provided challenges for our current system. We do not have currently the communications, navigation, really surveillance infrastructure to fully support large operations at this altitude. So up there are unmanned and manned vehicles, and they have disparate speeds, slow-moving balloons and long endurance winged aircraft. We have some high-speed fixed-wing vehicles up there with the military, and we're also seeing a reintroduction of high-speed fixed-wing supersonic aircraft. In some cases, it's a constellation moving around together. In other cases, it's point-to-point. And for some, like commercial space, it's transitional operations. So what are our needs for this upper airspace, this higher airspace? One, our ATM scalability, our current manner of providing ATM services cannot cost effectively scale to meet the needs envisioned in the upper E environment. And our current ATM services may not be desired in upper E environment. You don't really need a controller to monitor aircraft moving in the teens to 20s of airspeed. So we need solutions that are needed to scale beyond the current ATM infrastructure and our current manpower resources, and to promote shared situational awareness among our operators. So what is ETM, or higher airspace, for us? We want to adopt a community-based cooperative traffic management approach to ensuring separation between the vehicles that are in this new class of operations, and we want equity of access to the airspace in an environment where ATC infrastructure and services are limited. Just like in UTM and potentially UAM, we want to utilize industry's ability to supply services under our FAA's regulatory authority. The FAA will not delegate the airspace to others, but we will use our authority to let others provide services in this airspace. And it relies heavily on information sharing and data exchange. If you're not doing voice communications with controllers, then you must be sharing information operator to operator, vehicle to vehicle, and operator to the FAA to achieve safe operations. One of the requirements will be that operators have to share their flight intent with each other, coordinate to deconflict, and to safely separate the movement of their vehicles. And the airspace management needs to encompass all the infrastructure, policies, procedures, service, and personnel required to support these upper E operations. So the principles it's notionally defined as flight level 600 and above. The operators may include, but not be limited to, commercial, public, and research entities. The supporting architecture and services need to be scalable to meet the needs of the market forces. We're starting small now, but there could be a very large demand up there. Safe separation and demand balancing are enabled through harmonized ETM airspace interactions, procedures, and compatible technologies. Again, it's our airspace and we're keeping it. Operations will move across multiple flight information regions, and the ETM concept will be developed in consideration to the global application. And that much of the reason for that is it is an industry-led infrastructure, and it's heavily dependent on information exchanges, both of which have to be global in nature. So what do we expect up there? We expect cooperative separation. It can't be IFR because the FAA is not providing separation services. It can't be VFR because there is no such thing as visual operations with these autonomous vehicles. But what we can do is take the principles of VFR, which is a cooperative separation environment based on rules of the road, and we can apply that in this airspace. So the operators are responsible for maintaining separation from one another and avoiding unsafe conditions. A federated set of services from those provided by ATC, facilitated by these operators and their third-party support, will be the network in which the information exchanges occur, not through air traffic control. And the access must be equitable. We have to make sure that operators cannot optimize their own operations of sub-optimizing the ETM environment as a whole. We will still have ATC-provided separation because this is not uncontrolled airspace, it's Class E airspace. So vehicles transiting to and from operating altitudes through controlled airspace will have to go through ATC services. So from the ground up until flight level 600, you will be in ATC separation services. Above that, we will still have ATC services for those aircraft which choose to be IFR aircraft or which we require to be IFR aircraft, manned aircraft, supersonic aircraft. ATC separates the IFR aircraft from special use airspace today and will continue to do that. ATC will still separate IFR from IFR and from cooperative vehicles using NAS data sources and cooperative operations data. By sharing your intent and your modes of operation, ATC can assure that the IFR clearances delivered will not impinge upon the cooperative vehicles and where they are. We will not provide services to cooperative operations. So how did we get to where we are today? We've conducted a series of tabletops with industry and NASA and state agencies. And this includes both the slow movers, the balloons, the fixed wing operators, as well as the supersonic operators. We conducted one in April of 2009. We focused on understanding what they plan to do. We established the ETM principles, and we established the development responsibilities for industry, FAA, and NASA. Not everything will be developed by FAA and NASA. The community-based rules will be proposed by industry, reviewed and approved by the FAA. We held another tabletop in December of 2019, where we considered the concept considering ATC interactions, transit to the airspace, and from that we developed an ETM concept of operations document, which will inform engineering plans and considerations. This document captured what we heard from industry, what we agreed to at the tabletops. It is not a validated concept, but is a baseline concept from which we can work our research and our interactions. And we published that in May 2020. It's the overarching principles. We have operational threads, we have roles and responsibilities, and we have high-level operation requirements to get to and from this airspace. And because many of these operators actually wish to fly as low as 55,000 feet based on atmospheric and sun and everything else, we have what we consider a flexible floor concept where we can adjust how low they can be and still run cooperative operations, and rather than requiring them to always stay above flight level 600 for cooperative and then enter into ATC, they breach that floor. And finally, this is all about a shared collaboration with NASA, with its research programs and its flight test plannings, with the FAA, our subject matter expertise, our concept of operations, and especially our role in defining information requirements and the roles and responsibilities, and the integration and interoperability needs. Industry is providing their use cases, their architecture, proposing right-of-way rules, proposing equity rules, participating in flight tests and demonstrations, and working on the readiness of technologies. These two bubbles on the left are the reason why this cannot be just an FAA and industry only activity. Information requirements, architecture have to be able to reach beyond the FAA's domestic airspace into the rest of the world. And that is why we are here to discuss how can we globally come to a harmonized set of architectures, information exchanges, and cooperative separation rules. Thank you.
Okay, now next is Mr. Villa, whose presentation is being displayed on the screen. Please, Vila, go ahead.
This presentation will be about the experience of the Peruvian state with the high altitude platform stations, technology of the Google Loom project. Hubs are stratospheric platforms that operate up to 22 kilometers of altitude, and it's capable of providing a coverage of 600 square kilometers or higher, which is an advantage compared to systems based on ground or satellites. The platforms are powered by solar energy. All their communications and navigation equipment is usually aboard. One of the advantages of this technology compared to satellites is that their hubs stations can be returned to ground. One of these projects has been carried out by Google Loom. In Peru, Google balloons are operating in trial mode and have on board all the equipment required for safe air navigation. The Loom project consists in a net of balloons that travel out of space. The balloons are connected to their local communications provider and are intended to provide connectivity to those who live in remote or rural areas and don't have communication or internet service. The balloons float above 50,000 feet in the stratosphere, exceeding regular aircraft high levels. In Peru, we have two opportunities in which Loom service has benefited people. In 2017, Peru suffered a phenomenon called El Niño Costero. Unchained heavy rains causing floods in numerous cities in the north of Peru, affecting the communication of those cities. On that event, it was possible to provide communication via mobile internet to the residents in less than 72 hours, thanks to the accessibility from Telefónica and the Loom balloons. On May 2019, an eastern region from Peru suffered a magnitude 8 degrees earthquake, affecting communications. During several weeks, the residents of those areas were able to access basic internet connections since the coverage of each balloon is approximately 50,000 square kilometers. In order to use the service from Loom and Telefónica, there were several actions that had to be carried out in compliance with national regulations. Within the MTC, through the Directorate General of Civil Aviation, is responsible of the aeronautical sector by granting the authorizations for air operators. Likewise, the NSP must comply with the operational procedures necessary for air operations in this particular case. Also, in the MTC, the communications programs and project directorates and the General Directorate of Telecommunications Authorizations are responsible of granting the licenses and authorizations for telecommunications providers. The second sector involved in this process is the Ministry of Defense through the Peruvian Air Force, through the units COMCA and SIDAN, whose objective is to protect the security matters of the Peruvian states and the areas prohibited. On 2016, As part of the Loon project, the company Google Loon requested permissions for unmanned balloons to hover above 60,000 feet on Peruvian airspace to carry out a technical feasibility studies of internet connectivity. The company was required to submit an application specifying the data of the operation as must meet the requirements and conditions established in the aeronautical regulation of Peru, in addition of having a coordination protocol procedures with the ATSP CORPAC. Likewise, the company must have the corresponding authorizations for the use of frequency from Telecommunication Authority. In April 2016, the letter of agreement was signed between CORPAC and Google Loon, where is established the framework for coordination and communications between CORPAC facilities and Loon's unmanned free balloon. In addition to the law between CORPAC and Loon, there is a second law between the Peruvian Air Force and Loon, which essentially addresses operations in prohibited or restricted zones. This document is part of the law signed with CORPAC as an appendix. Finally, it is required authorization for the use of frequencies from the telecommunications provider. In this case, Telefónica del Perú carry out the processes. Currently, the Multisectoral Commission of the Frequency Assignation National Plan is conducting studies in order to determine the ideal frequencies band and also that they meet the recommendations from the International Telecommunication Unit. The letter of agreement with CORPAC includes essentially responsibilities of each side: contact information, active flight coordination, descent coordination, planned descents, unplanned descents, loss of balloons reporting position. The procedures to be followed by Loon are established, as well as the requirements for the hot air balloon, and in addition to meet the Civil Aviation Law of Peru and the requirements specified in the Peruvian regulations. Besides, the balloons must be equipped with a transponder capable of Alpha and Charlie mode, and the control center will assign a code before launch. Unless otherwise requested by air traffic, transponder will deactivate when balloons operate above flight level 600. On the other hand, the Loon project provides access to a web portal for monitoring the flight of balloon mission by assigning a username and password for such purposes. The arrangements with the Air Force were essentially due to the flyover of the prohibited and restricted areas where the Airspace Control Command, as part of the Air Force, is responsible for. Besides the transponder use, in cases where it is intended to fly below 50,000 feet over prohibited or restricted areas, it must have an authorization from the Air Force. If it's necessary, the Air Force can apply inspections to the Loon system, for which a controlled descent must be coordinated for operational inspections on a random basis. The spectrum for hubs was one of the topics discussed of the last World Radio Communications Conference, where the International Telecommunication Union identified frequency bands for the use of this technology in the Americas region. Finally, the frequencies allocation to the public service concessionary were required under the temporary allocation arrangement for the purpose of making technology trials and evaluate the performance of Loon technology under the particular geographic and climatic conditions of the country. The conclusions: the first, the hubs technology experience in Peru has been with the Loon project, which made possible the provision of communication to vulnerable communities and during natural disasters events. For the use of this technology, the participation of several government institutions from the Ministry of Transport and the Ministry of Defense has been necessary. As per the MTC, two established procedures must be followed. The first one refers to the authorizations for the use of the radioelectric spectrum, and the second one is about permissions to fly in the Peruvian airspace. And finally, the letters of agreement were signed to assure that the operations of the balloons that provide the service are carried out without affecting operational safety and security matters. Thanks a lot.
Thank you so much. Now it's time for the next presenter. Bear with us as we bring him on board.
Hello, my name is Henk Hoff. I'm project manager of the ECHO project. ECHO stands for European Concept for Higher Airspace Operations, a European project. And with ECHO, we are preparing the ground for safe and efficient higher airspace operations in Europe. And that is necessary because there's new need, new demand that we are seeing at the horizon, and not only in Europe, but also other parts of the world. And this new demand is quite different in characteristics. We have the HAPs, such as the Thales Alenia Space Stratobus, the Airbus Zephyr, but also high-speed vehicles, supersonic and hypersonic, like the Dassault Aviation vehicle, but also commercial space. So all of that is planned to operate in the higher airspace or to transit through it. My ECHO colleague, Mark Velez, will explain a little bit more about the types of characteristics that we are seeing with these vehicles. Of course, the differences in these characteristics, they bring challenges. Of course, one of safety. We need to make sure that it all can safely operate. But higher airspace vehicles will also transit through the airspace below the higher airspace, so we need to make sure that it safely can interact with the conventional airspace users, but also the future ones. But last but certainly not least, we see it also as a big opportunity. And with ECHO, we are trying to explore that to the maximum extent possible. One of innovation and one of transformation. There are lots of new companies, new businesses that want to make use of the higher airspace. They don't have often an aviation background, but they bring quite a lot of innovative ideas. They have a long history in the IT business, so that's a value that we should use and explore. Second reason is that the higher airspace until now is quite empty and there are not a lot of legacy implementations. So that opens a lot of possibilities and indeed opportunities. Some key principles that are important for ECHO. We're not only looking at the vehicles that we see in the higher airspace today or that are at the horizon, but also those that are on the drawing board or even in a conceptual phase. We really want to make sure that the CONOPS is a future-proof basis for higher airspace operation. The CONOPS should become a comprehensive and innovative and feasible document on which we can base future developments. And that's for the near, mid and long term. So it's not only for the long term, but also certainly for the near term operations. And some keywords here: safe, orderly, sustainable, robust and scalable are very important in the ECHO project. We will of course also look at how higher airspace traffic management interfaces with air traffic management and with space traffic management, because it should be a smooth transition through all the airspaces. Also very important is that we consider the higher airspace as an integral part of the network from an airspace point of view, but also from an operational and systems point of view. And as far as manned aviation is concerned in the higher airspace, we will apply the fundamental principles of safety and environmental standards. Very important. So ECHO develops the CONOPS, and we do that based on a thorough and comprehensive demand analysis and research analysis. But we also collaborate closely together with EASA, and EASA works on a regulatory framework and an regulatory impact assessment. And the demand analysis and the CONOPS development are very important inputs to that work. Here you see a list of the ECHO Consortium, and you see that it brings together quite a lot of interesting and different players, and it's a good team to develop the CONOPS with. This figure presents a bit the approach we are following in ECHO. So we do the work, of course, with the consortium, but we also have an advisory board through which we bring on board the European institutes, EASA for the regulatory interface, EDA, the European Defence Agency, ESA, European Space Agency, but also other European actors and also non-European actors are in the advisory board to advise us on the way forward, on proposals we have to provide input to our work, etc. But also we see a lot of an intensive involvement with the wider higher airspace community. And for that we organize a total of 3 large-scale workshops to talk about various themes. And during these workshops we will present ideas, proposals, and we'll solicit feedback. Buy-in for us is a very important principle also that we are following. The project consists of 3 main work packages besides work package 1, project management. Work package 2 is research analysis, then demand analysis, and work package 4, concept of operations. My colleague Mark Vales, I talked earlier about, is work package leader of demand analysis, and Drago Stonia, who will replace me in the panel, is the leader for the concept of operations development. So in the research analysis, we will look at existing research and literature to make sure that we are not reinventing the wheel, but really base our work on already existing findings, a very important step in our development. Demand analysis, that will also be a very important step and foundation for the CONOPS of operation and also for the regulatory work. Of course, at the moment, there's not a lot of demand, but we see quite a lot of developments taking place. For example, in Europe, there are a number of countries in which ideas are explored to deliver 5G services using high airspace platforms, the HAPs. And it's very important that we not only have information about the characteristics of the vehicles, but also the volumes. What are we talking about? 100,000, 10,000 operations a day. It's very important. And that will drive the short, medium, and long-term CONOPS that we are going to develop. In work package 4, the actual development of the CONOPS, we will first start from a set of principles that we are working on at the moment already. These principles are on performance, on innovation, on safety, on network principles, and so on. And we also, as I already said, approach it very much from a European network perspective. We see it very much as a continuum of airspace and a continuum of operation through the various volumes of airspace. So in summary, ECHO, as I said at the beginning, is preparing the ground for safe and efficient higher airspace operations in Europe. We, by doing that, are enabling and opening new business opportunities that we are seeing, and some keywords: safety, performance, innovation, and collaboration. And also buy-in, I would really put here as a keyword. So with that, I really thank you for your attention. If you want to know more about ECHO, you can visit this website. We will also have a dedicated website, which will be communicated as soon as possible. And for more information, you can also send me directly an email. Thank you for your attention.
Hi, my name is David Hansel, and I'm the Global Head of Aviation Regulation and Policy here at Loon. And it's my pleasure to speak with you today about the challenges and opportunities in unlocking the stratosphere. And I'd like to provide these perspectives from the point of view of the HAPS Alliance, which is an international conglomeration of aerospace manufacturers and operators, alongside telecommunications firms, which are working to address these challenges and opportunities in real time to help unlock the stratosphere so that we can all benefit. By now, you've undoubtedly heard the perspectives of regulators from around the world, including the Federal Aviation Administration, who has said, both in public statements and through the publication of their ETM CONOPS earlier in 2020, that the FAA does not intend to provide traditional separation services in Upper E once the vehicles have reached altitude. We think it's important to understand exactly why that would be difficult at best and near impossible at worst. And we think that revolves around 4 specificities within the stratosphere. First and foremost, as you can see from the image on the screen, the vehicles that typically we envision operating in the stratosphere vary greatly, both in their performance capabilities and in that performance itself over time. What I mean by that, as an example, the ascent rate of a Loon balloon, shown in the upper right, is a function of its internal pressure, which itself is a function of the temperature and the time of day. So a rate of ascent that we may be able to achieve at 2 o'clock in the afternoon when it's sunny and warm is not necessarily the same as what we could achieve at 2 in the morning when it's dark and cold. Likewise, the maneuverability of a fixed-wing HAL like Airbus's Zephyr, shown in the bottom center, is a function of its battery management constraints, and those can vary greatly over time as well. And you start to see here that you cannot rely, therefore, on a static performance-based navigation system when the variables upon which that system relies vary so greatly themselves. Next, you realize that these aircraft are conducting a wide range of missions. Some of these operations could fly for 6 months to 12 months, if not longer. Navigation systems may replan these routes from minute to minute, therefore making point-to-point navigation, what we see in standard aviation today, just unrealistic. Instead, these aircraft are changing their direction in response to the environment around them. And today's air traffic control systems just don't envision a possibility like that. And since these trajectories are not a series of points, but instead different probabilities, over time those probabilities become less and less clear, again hindering the capabilities of a traditional air traffic control system to envision and therefore safely deconflict these types of operations. Next, you realize that from takeoff to landing, these aircraft are going to operate across myriad airspace classes, from surface to flight level 180, transitioning through Class A, finally arriving up in Class E. But even while on mission, many of these aircraft will climb and descend in order to meet their battery constraint requirements, which I mentioned earlier, or to accommodate mission demands that may necessitate operations from higher or lower altitudes above and below flight level 600 at any given time. When you contemplate that this is happening over a 12-month time span, you really start to see the light between what we are envisioning in the future and today's air traffic control systems as they exist. And finally, it's important to understand that these are global operations. While many aircraft can fly incredibly long distances today, no one but these stratospheric operations are envisioning flights that wrap around the globe several times over the course of 12 months. This type of international approach necessitates an agreed upon open standard that all operators and all ANSPs around the world support and contribute to. And that brings us to what we call collaborative traffic management in the stratosphere, or the CTMS concept, what the FAA refers to as ETM here in the United States. As discussed in their Concept of Operations, published in early 2020, the FAA acknowledges that the system is predominantly cooperative, providing optimal operational flexibility, which encourages operations that wish to fly with few restrictions. It realizes that cooperative separation is achieved via shared intent and shared awareness, wherein operators share both their flight's intent with each other and coordinate directly with each other to deconflict and safely separate trajectories. Now, this doesn't preclude an operator from using ATC-provided separation as you would during the climb and descent phases of your operation, but you have to accept these ATC-managed operations will receive less operational flexibility than cooperative operations based largely on the capabilities of the aircraft involved in those operations. The system also relies on a flexible floor or a deconfliction flight level, an altitude at which the cooperative environment can exist. And we don't think that this needs to be a fixed altitude. Upper Class E around the world is often defined as flight level 600 and above, while Class A remains below that. But in our vision, this cooperative environment can straddle both of those altitudes to maximize efficiency, not just for the users up in the stratosphere, but for the users who may fly at those higher altitudes while still under traditional ATC-provided separation. So what is industry's vision for such a concept? This architecture relies on the same high-level architecture that UTM has relied on. It's a federated architecture of operators and services which can exchange information through open standards. Operators are responsible for sharing their four-dimensional intent with one another, flagging relevant conflicts, and negotiating resolutions. When they're unable to perform these functions, operators can rely on third-party services to do it for them. A network of discovery and synchronization services ensure operators know who to communicate with and ensure that they have the most up-to-date information for their mission planning. Standards work is also critical for exchanging information with regulators and ANSPs. And interoperability, which leads to and relies on open standards, are critical in this international context. This federated architecture provides the ability for deconfliction services that are specifically tailored to the nature of each operation and that can communicate with each other using a common shared language. In this example here, on the left, one of these flights may never be approved because of a potential conflict that may exist between these two flight paths. However, when you contemplate that this may happen over an entire year, what does this say about how we efficiently use this shared limited resource? Instead, we prefer an approach where a system is constantly evaluating a vehicle's intent and the awareness of the operators that may be co-located in airspace nearby or in the same airspace. And instead, the system resolves traffic conflicts through in-time negotiation. So a conflict won't be flagged if it's too far in the future or if it's too likely to change. But once you enter into a negotiation time frame where the system realizes that there is potential conflict somewhere down the road between vehicle A and vehicle B, those two are given an opportunity to deconflict based on their mission demands. If they are unable to reach an agreed upon settlement within the time frame necessary, there's still a window for what we would refer to as fallback arbitration, where one vehicle will be required to maneuver out of the way in time for there to never have been a conflict in the first place, sort of the deadline for resolution to that conflict. And what this provides us with is a highly efficient way to deconflict traffic throughout the duration of a vehicle's operation, which again could be up to a year. CTMS would continuously update these intents based on this rolling window while in flight. So once these two vehicles are deconflicted, the system would continue to look at the evolving future of each individual vehicle and once again continue to do this deconfliction effort over time. Additionally, some operators will need to attach probability to their intent, as the four-dimensional intent overlap may not be sufficient to determine that a conflict must be resolved. What we need to do is find an appropriate timing at which resolving conflicts is relevant and then act within that space. We certainly appreciate that envisioning a new paradigm for traffic management is no easy undertaking, and we applaud the ANSPs and the regulators around the world who are leaning forward to try to make this happen, and we look forward to the opportunity to doing this alongside each and every one of them. Thanks so much for your time today.
Ladies and gentlemen, in the frame of ICAO Innovation Symposium and of its panel 7 on higher airspace operation, I am pleased to present hypersonic development for what regards their use in higher airspace. Moving very, very fast in thin air, or even in vacuum, propelled by carbon-free hydrogen, could become an addiction for the next generation. We are talking of traffic that is expected to boom in the coming decades, and if it works, it will last for long. My presentation will not be a list of various projects, vehicles, services which are currently next to fly or in development or at conceptual steps. I will try to disconnect from programmatic and economic point of view in order to address it from the laws of physics, in order to be sure that from the air traffic control management point of view, the bases are sound and will last more than politics. The first discrimination comes from the type of propulsion, able to bring you at hypersonic speed. Rocket engines work perfectly in vacuum, but also in atmosphere, while air-breathing hypersonic engines, like scramjets, will not be operational before 15 or 20 years with the appropriate level of confidence. Outer space in Earth's vicinity is a continuum, from and back atmospheric airspace, and it becomes more and more crowded. Trajectories are crossing both airspace and outer space at very high speed and worldwide, leading to the need of an integrated traffic management global system. The applications which can rely on proven technologies, here in green letters, will come first. First, A-to-A suborbital airplanes, like space tourism at Spaceport America, flying few minutes and coming back. Then A-to-B suborbital airplanes, space planes, sorry, able to cross the world in less than 1 hour. And then from orbit re-entry space planes, likewise the space shuttle, landing on Earth after a few tenths of minutes. Then will come the applications which need non-yet mature propulsion, here in blue letters. First, the hypersonic air-breathing cruise aircraft, able to connect continents in couples of hours, flying in stratosphere. And hypersonic air-breathing cruise space plane, reaching first thin density stratosphere before ignition of rocket propulsion in order to reach orbit. In the meantime, military application will use similar technologies on almost similar trajectories, but which are not ending at the same landing speed. Like for airspace zone, it will be mandatory to identify all flying craft in higher airspace in order to avoid wrong and tragic reactions. Now let's talk of flight domains. The frontier between subsonic and supersonic is sharp, just at Mach 1, but the wall of sound vanishes with altitude, and above 30 kilometers the boom becomes scarcely audible at ground level. Hypersonic gradually replaces supersonics above Mach 4 or 5 because air compression and friction reach temperatures that involve chemical reactions. For specialists, aerodynamics let room to aerothermodynamics. From there, physics depend not to square of speed, but to cube of speed. And related mechanical and thermal effect generate a structural limit below which the air density make any material to melt or burn. Above 60 kilometers of altitude, friction decreases and it vanishes above 100 kilometers. mass of air, which can be ingested by air breathing engine, decrease with altitude and air density, making an aerobic corridor out of which this type of propulsion cannot work. Air plasma temperature interfere with electromagnetism over around Mach 8, generating a radio blackout, at least on the intrados sides, toward Earth. And above 8 kilometers per second, the speed centrifuge on Earth orbit. With regards to suborbital and from orbit application, the range of speed when crossing the control airspace are not such different, even if generally supersonic. Nevertheless, the profiles of climb and descent are different, as are the time between liftoff and takeoff and the in-route conditions. Preliminary studies performed in the frame of European ECO project identified two major typologies for hypersonic application. First, regional and high speed conditions, and second, worldwide, global and very high speed conditions. Next step, towards safe, sustainable and fair standards compatible with manned aviation include first, identification of all types of known and planned vehicles and operation that will make use of the higher airspace. Second, the consolidation of needs generated by those new entrants. Third, the translation in concept of operation. And then the proposal of common rules. And this is the object of the SESAR program decided by European Commission. Thanks a lot for your attention, and for questions, please use the chat.
Thank you so much for the panelists and their presentation. Christine, are you in there?
Yes.
So are we done with the presentations?
Yes, the presentations are finished. Yes.
Perfect. Now, next is we are entering into a Q&A session, and we are going to start with Steve Bradford and Dragos. This was a very educative and informative session, I must say. And many of us have definitely gone with a basket of knowledge and a lot of information in this new technology. Now, both Steve and Dragos, for you, what is the role of ICAO in ensuring a global approach to higher airspace operations? Other panel members should also be able to chip in. But Steve Bradford, please go ahead.
Okay, so in fact, there was a question on the questions that kind of leads to the same thing. It's important for ICAO to help sponsor and support our interactions. Someone noted that the FAA's charts for our directed tabletops in our conversations, we only included operators and U.S. entities. And that's because we have limitations on how we can meet with international people when the FAA is facilitating a meeting. We have met with the operators in other forums in which there are many international partners. We also are in the middle of negotiating a new research program with SESAR, in which our Upper E and the ECHO programs will start to work. But those are all bilateral, and they're not all encompassing. So it's really important that ICAO sponsor this, provides a forum for us to interact with each other, participate as more than subject matter experts, because many of us have limitations on how we can directly interact outside of an international forum. And it's important because this has to be international.
Well said. Dragos, what's your comment on that one?
Thank you, Silas. Thank you, Steve. I've also picked up the questions asked on the Q&A, and it's quite clear that we will be dealing for new entrants with some fundamental elements of the ATM system. Think classes of airspace, think flight rules, and I don't think that conversation can happen anywhere but through ICAO. And obviously, if we want this industry to be able to operate globally, the rules need to be defined at global level. I think this is a must-have solution, and the more we will be dealing with finding the properties of solutions that are acceptable also for traditional aviation, we will find that current setups and current solutions may and should be improved. Thank you.
Perfect. Dragos, while you still have the mic, how important is airspace organization for seamless global operations?
I think this is key, and I speak from European experience where we've understood the added benefit of not having the airspace fragmented. I think we're looking to understand what it is the best optimum solution that could be applied over a region. And we see that airspace organization is the key that we have to focus on. Think also about the link between spectrum protection for radio frequencies and the way we define airspace volumes. And there's a direct connection there that we need to be very mindful of. And I come back again to the type of services that we provide and we intend to provide. Some of this may not yet be defined, and we need to be very mindful that state sovereignty and provision of services need to go hand in hand for this. And I see airspace organization as a key direction for the rest of the community, mindful of the fact that in some regions we would not have big volumes of airspace, but we would have to deal with cross-border situation. And therefore, I think it's important to explore this type of discussions at global level. Thank you.
Now, my next question is directed to all the panelists. Will all the panelists please turn on their camera? And the question is, can the traffic management solution for higher airspace operations be an incubator for ATM? Whoever is free to respond to this. Can the traffic management solution for higher airspace operations be an incubator for ATM?
Yeah, if I may, this is David. Thanks for the question. You know, I think one of the wonderful things about aviation, and I think FAA really does a wonderful job of typifying this behavior, same with EASA and Eurocontrol, is that we learn from every input to the aviation ecosystem. There is something that can be taken from every effort, whether it's in the negative or in the positive, and adopted in a manner that is helpful, not just to the operators, but to the ANSPs and to the world around us. So yes, I think that any learnings we get from high altitude traffic management solutions can be applied more broadly, even beyond just that ecosystem, in the same way that a lot of what we have proposed is based off learnings that we saw in UTM and integrates standard air traffic procedures that we see in positive controlled airspace as well. So yeah, absolutely. I think that is the standard that aviation ecosystem has utilized for decades now to great success.
Excellent. Now, Mark, what is the business economic case for hypersonic vehicles in the higher airspace?
Yes. Maybe we have to remember that before COVID, the air transportation was somewhere more than 600 billion per year business, and growing at 8% business per year. So we really believe that being able to move 20 times faster on in a carbon-free mode with hydrogen, for example, with green hydrogen, should attract some passengers. Just a few of them will be enough to make the business model. And we really believe that flying daily over the dense airspace in a safe space plane using hydrogen rocket propulsion is an experience that we really wish it to the next generation. The people born in the beginning of 2000 should live that. And let us remember that we need air to sustain ourselves in aviation, but then after that, the speed is really a bargain if you want to go very, very fast in air. So going over and surfing is just like hydrofoils or something like this. You go above, then you have no more drag, and then you can reach speed which are about Mach 25 when you re-enter in the atmosphere, and then you use once again air in order to be safe and to be able to land without being obliged to have a retro rocket, things like this, because we see today that for launchers there are solutions. But frankly talking, we don't believe that it will be safe enough to transport people with the same level of security that what we have today in aviation.
Perfect. Back to you, Mr. Dragos. How do we ensure that higher airspace operations do not have a disproportionate impact on operations in the airspace below?
I think it starts with proper planning. Obviously, we consider that these operations need to be part of the larger picture we have on the entire European ATM network. We have quite clear metrics for defining what performance of that network is, and therefore we understand what the various elements impact on each other is. And once we will have included new entrants as part of the regular planning, and we would have included them in the processes that we have designed for managing the network, then it's obviously easy to identify the delta and maintain that particular impact to a proportionate measure. The other remark I would like to make is that we need to make sure that we foster innovation and we allow this industry to grow. So I think there is a dynamic relationship. We need to make sure that everyone has access in a fair and transparent manner to network resources. We have transponder codes, frequencies, airspace identified as resources that we need to share. And obviously the criteria upon which these are fair and equitably shared, it's something that needs to be discussed by industry and regulators as a community. Thank you.
David, this is to you. How can one ensure innovation is used to support a future in which all users have access to critical ATM resources?
Who was that to?
That is directed to David, but whoever is willing to respond to it.
That's what I thought. I thought it was David, but I'll go ahead, David.
Yes,
Is it
go ahead.
this David or David Batchelor? I think me.
Yeah, David Batchelor is our facilitator.
David Batchelor. Okay. Yeah, you know, equitable access is a key underpinning of the utilization of this, you know, shared yet limited international resource. And equity access to that airspace has been and continues to be the foundation of rulemaking. It's the foundation of ATC operations around the world. And it is really critical to ensuring that it's critical both from the operator's perspective and what I've seen from regulators and ANSPs that we are constantly considering how is this being done in an equitable fashion. And I think when you go into the effort with that as a foundational sort of pillar of your approach to airspace access, you're guaranteeing that on the back end. I also think that at what we've seen in the past, particularly the past 5 years, as we've been developing regulatory approaches and partnering to develop an approach to the concept of operations, all the operators and manufacturers in this space, we've all approached this from like, this has to be equitable. We all have to have equitable access to this. And as long as you have the technical acumen to operate in this airspace, you should be entitled to that equitable access. And ideally what that yields then is equitable access to the users who are utilizing the services of those vehicles, whether that's supersonic aircraft, whether that is communications balloons, or surveillance that government can use to look for fires around the world. We think that pillar approach sort of guarantees that for all the users, including ANSPs, the folks on the ground, and the operators themselves.
So can I answer that too?
Please go ahead.
So let me take it a little bit different approach on that one. Equitable access says that there's lots of access that we just need to make sure that it's passed out appropriately. If we don't do something like this, and we continue to use our techniques that we use at these highest altitudes, the typical ATC construct, we require a lot more airspace for each operation. So equitable access ends up being, how am I going to ration the airspace that I've divvied up for individual operations because I'm using the traditional methods. This whole goal here is to provide an ecosystem in which these vehicles can actually fly much closer together because they are cooperatively separating. They actually open up more capacity. And then we just have to make sure the equitable is one of these operators figuring out ways to disadvantage another operator. But without an ETM or an ECHO or something else, we'll be talking about how do we do demand capacity balancing on a scarce resource, because our current operations require lots and lots of airspace, lots of buffers, and eat up the capacity.
Well done, excellent. So, Paulo, in the experience of Peru, what measures have been implemented to ensure the safety of air operations in the event of unplanned down a balloon?
Okay, thanks, Silas, for the question. In Peru, actually, in response to LUN's requirements to be able to operate in the Peruvian airspace, our main objective is in the air navigation service was to ensure the safety for air operations and for the balloon, obviously. In that sense, it was coordinated with LUN personnel that the balloons keep their transponder active and fly at flight levels above 60,000 feet in order to avoid possible effects on air traffic management. Additionally, there are events of the balloons which were evaluated between the parties, LUN and air traffic service provider. And of the result that we have is the letter of agreement between CORPAC and LUN, which clearly establishes the actions to be followed in a schedule or an unscheduled descent, always ensuring the safety of operations. In summary, before the balloon operations, the necessary arrangements were made so that their operation does not affect the safety. And since 2016, the descents that we have always been carried out in compliance with the letter of agreement without any inconvenience.
Excellent, excellent. So, Mark, what are the potential showstoppers of hypersonic developments using higher airspace?
I think that the first one come from the fact that at this speed, the traffic will be inevitably international. There is no interest to go so fast if you don't go far. So it means that we will have first to face the need to share the vision and to share the rules and to have somewhere common regulations, which can be made of law and made of usage, and clearly an harmonized air traffic management at the international level is a key enabler. And very probably it's the one which need to be started from now and with a sound exchange of vision in order to be sure that there is a common interest to succeed. And the second is directly linked to the high level of energy and complexity, which are very high because, of course, we are not talking of vehicles which are very light and very small. And there, we believe on our side, being myself, I've been working both for rockets and for aircraft, and we believe that we must avoid that some kind of crazy rocket dreamers. I'm not talking with the real one, but there are a lot of things that we see people making some advertising on some possibilities, and we are afraid that they can jeopardize the business, taking too much risk and put at risk globally the air traffic. So for this, there is a set of industrialists. We believe that the safe hypersonic space planes will rather be planes coming from the aeronautical background and legacy, using, of course, speed rather than the reverse. We don't believe that industrialists that are making launchers will be able to go from the today. It's a pity, but you have to remember that the space shuttle, which was a marvelous vehicle, has a rate of lethality which is very, very high, 1%. So, of course, it's very, very difficult to come from rockets to go to the level of security, safety, and which is the one we need to have a fair business like in commercial air transportation today. So at the end, those two drivers. One is sharing the rules, and the second one is achieving the correct architecture in order to be sure that the customers will want to fly in the craft.
Oh, perfect. So this one is an open question to all the panelists, whoever grabs it first. What would be critical interfaces with non-aviation actors like space agencies, the militaries, that you foresee? Whoever is willing to grab this question.
Maybe I can keep just to say that probably legal matter will be a major driver. So we have really to embark with us all the legal people that can help to pave the way for the framework that will be needed in order to define how to use this new volume, which is the space. I mean, the in-between airspace and space.
Okay. Any other comment from any of the panelists on this question? Looks like we are running out of time.
Can I add to that, Silas? I think it's a crucial part of our analysis because, and you'll have seen on the chat, contingency management is crucial to ensure that these operations can grow. And we're looking at new type of operations, at least in Europe, when we're looking at launches from Europe, and our interfaces with the space agencies will be required to make sure that we cover all contingency scenarios. Now we're looking at colleagues over the Atlantic who've had experience and have set up a particular way of interacting. And we understand that we need to have more direct communication and real operational exchanges as opposed to strategic and then perhaps pre-tactical exchanges that we've had so far. So to me, that's one of the key areas that we would need to account for. And on the military side, I think the air defense and security aspects need not be overlooked. Obviously, when we look at the type of operations, there are new scenarios that need to be accounted for, and all of this will have an impact on how we assign resources and how we interface with colleagues that may be cross-border. And therefore, at least in ECHO, we're looking at this as something that needs to have a solution that's driven by international regulation as well, because we would not simply be in a position to apply a single state rules, not in the European context. Thank you.
Steve, the discussion is taking us towards desired international coordination. So there is a need for international coordination and combined effort to support future operations. What plans do you have, and how will your organization initiate that effort?
So we want to enter into bilaterals. Using our bilaterals, we want to enter into negotiations. We also were working through other international organizations, like we work with AIA, and through that AIA, where industry can come together to help. We use whatever mechanism we can to try to engage. So, like I said, we're going to include this in the SESAR joint undertaking, next work package. We stand ready to attend and support other international forums for which we have agreements in order to work this forward. But a more holistic framework in which we can all engage would help, because there are limitations to our level of participation in certain types of organizations based on our federal advisory rules and things like that. But we're moving out as often as we can in as many places as we can.
Super. So while we still have the microphone, since this concept involves new information exchanges and new cooperative separation procedures, what roles do you think that standards bodies, NSPs, and legislators have to make this real?
I believe that once we get to a more detailed concept with the type of information exchanges we need to make, both strategically and tactically. Now, tactically here is hours, I believe, because for many of these vehicles. Then I think we need to go to the standards bodies and use those as forums for performance of the information, but the formats and et cetera, we'll have to see whether one of our existing XMs will support this, or do we have to come up with something different? But it's really important for us to work through standards bodies so that people can use that as the basis for their development, for their networks, and for their interchanges. And we've done this, with promoting FIXM for flight information, and AXM for aeronautical, and WIXM for weather. We may now have I don't know what the acronym would be, but if we'll have a new exchange model potentially for long-term intent, and especially since I don't think a standard separation is required here, since different vehicles have different characteristics. It really is, what is that critical area around the vehicle that we need to protect, and that has to clearly be in the exchange model also.
Any comment from other panelists on this panel? On this one, before I go to the Q&A session, the audience has been sending in questions. All right, looks like we are good to go to the audience and hear their questions and respond to them. I will give a summary of the questions that we have picked from the audience. The most prominent is, how will the various concepts of operations handle the state's occasionally requirement to operate in higher level airspace without sharing information with other users? Information and operational security for defense matters, blah, 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 blah.
Yeah, Silas, I can speak to that a bit from what we've seen on the operational side. Obviously, states maintain the jurisdiction over their airspaces, and today in standard aviation, they operationalize that through partnerships with their air navigation service provider. So if a state aircraft has a prioritization to occupy a certain piece of the sky, they operationalize that through the FAA here in the United States as an example. That model doesn't have to be different or unique for high altitude operations. We envision a system whereby states, particularly defense assets, can interrogate a collaborative traffic management system so they can receive a holistic, top to bottom situational awareness for their mission planning, and then plan their mission accordingly. And based on their own prioritization, if they say, okay, we can avoid that piece of sky, that's fine, then great. Then we as operators never see them. And we're totally happy with that. And that's not unique. If there was an Airbus 380 100 miles away, I don't need to see that either. So that in that way, that's not unique. But if the state determines, no, we actually need to be in that airspace in order to provide for the security of our population, then we move. There's no debate about that. I think the key is making sure that everyone has access to that system so they can smartly plan their missions accordingly.
Excellent. So as we move towards the end of our discussion, I request all the panelists to have a 2-second last second contribution. So we start with the alphabetic.
I just want to say thank you, and I really do believe it's going to be all about networking and sharing information in a secure manner.
Super. Next, Dragos.
I'd like to express my thanks and gratitude for allowing us to be part of this panel. I think it's been very interesting, and we consider this to be the first step in a very long journey together. Thank you.
David, go ahead. Hansel, go ahead.
Thank you so much for the opportunity to speak with everyone today. Very much appreciate it, and we certainly do appreciate the forward-leaning efforts by regulators and ANSPs, such as in Rwanda, in the United States with the FAA, in Europe, and also in Australia, particularly with CASA and Air Services and their participation. It's been and continues to be an incredibly collaborative effort, and I'm looking forward to the future. Thank you.
Super. Mark, please go ahead.
Yes, just thanks a lot for everything, and to everybody. And just to recall that the ECO project will propose 3 workshops open to almost everybody. I mean, also the people who want to contribute in the coming 18 months. So there will be some opportunities to share information and to address every kind of topics.
Paolo, the floor is yours.
Thanks for the opportunity, Silas, and thanks for to share with those panelists of the high level. So we have a point of view of the state, how we can use this technology. So we have a lot of work to do besides. Thank you.
Excellent. So we now go towards the end of our session, and we are going to go into a summary. And here are some of the quick takeaways for today's discussion. It was very evident that implementation of higher airspace operations can establish communications in a reasonable amount of time to remote areas and communities, especially after natural disasters. A need for legal framework and support for the establishment of national legal instruments through collaboration and coordination with different government agencies is of paramount importance. And continuous conduct of workshops and consultative meetings between stakeholders so as to share new and innovative ideas pertaining to high airspace operations. It was very clear that a higher airspace operation needs to consider safe movement of vehicles as they transit from their higher airspace to the lower airspace in an orderly and sustainable manner. There is a need for international coordination between the higher airspace users. In closing of this session, we would like to thank the panelists for their time and participation in these lively discussions. We also thank ICAO, ATCA, and SESAR, and most importantly, the audience for their participation. I will now hand over to the organizers to close out the panel event. Thank you so much.
Thank you very much, Mr. Silas, and thank you very much for moderating this session. And like you said, thank you to the panelists for a really interesting discussion on what's going to be a really exciting topic for the future. So just to say, we are now moving to a break, and we have a global networking coffee, which is being co-organized with ATCA and ICAO. And for this, you have to switch to a different platform, which is being hosted on Remo. This is something which ATCA has set up. I participated yesterday in the Global Networking Coffee, and I must say it's a really interesting platform to use. You can enter the room. There are a large number of tables. You can look around the room, see who's there, see who's at which table, go and join a table and have a chat with those people, then jump to another table. So I really would recommend you try it out. As I say, it's a global networking coffee, so we'll have participants from all three of these events. It will run for 1 hour following this. Although I would also remind you that for those of you following the SESAR Innovation Days program, the next technical sessions start on the hour at 4 o'clock Central European time, so in half an hour. Anyway, with that, thank you all very much, and see you soon. Thanks.
Thank you.
Thank you all. Thank you.